Hello, this is second session and day 1, and this is my first lecture in chapter number 2 in NCERT, that is electrostatic potential and capacitance. In first chapter we have discussed about the electric charge and electric field, and now in this chapter we shall discuss about the electrostatic potential and capacitance. This chapter contains two parts. The first is electrostatic potential and then capacitance. Now first we shall discuss about the electrostatic potential difference and electrostatic potential. We know that what is electric field? Electric field is the region around a stationary charge in which another charged particle experiences electrostatic force, and that region is called electric field. The strength of electric field can be expressed in terms of a vector quantity, and that is nothing but the electric field intensity. And what is electric field intensity? Electric field intensity is the electrostatic force experienced by unit positive test charge particle and the direction along which a positive test charge particle experiences a force is called electric field. This is the direction of electric field intensity. So this is the vector quantity, and now we shall discuss about a scalar quantity that represents the strength of electric field. The strength of electric field is expressed by a vector quantity, that is nothing but the electric field intensity, and also the strength of electric field can be expressed in terms of a scalar quantity, and that scalar quantity is called electrostatic potential difference or electrostatic potential. For electrostatic potential, we shall discuss about the work done. In electric field intensity, we have discussed about the force or electrostatic force experienced by unit positive charge particle, and here is the work done in displacing a unit positive test charge particle from in an electric field, and that is nothing but the electrostatic potential and electrostatic potential difference. Let me explain by an example. This is a kind of electric field, and in this electric field, when we put a positive test charge particle Q, then this charge particle experiences electrostatic force, that is called electric field intensity, and the direction along which this positive test charge particle experiences the force is called the direction of electric field intensity. And also, when this charge particle is placed in electric field, it will experiences an electrostatic force, and when we move this charge particle from one point to another point, then let this is point A and this is B. So we have to do a work against this electrostatic force, and this work done is called the electrostatic potential difference between these 2 points. Again, I am explaining. When a positive test charge particle is placed at a certain point in an electric field, it will experiences an electrostatic force, and when we move a charged particle from one point to another point in an electric field, then we have to do a work against electrostatic force, and this electrostatic force is called electrostatic potential difference between the points. So this is called electrostatic potential difference. Electrostatic potential difference is nothing but the Work done in displacing a unit positive test charge particle from one point to another point in an electric field is called electrostatic potential difference between the points. Again, I am telling what is electrostatic potential difference. A work done in displacing a unit positive test charge particle from one point to another point in an electric field against electrostatic force is called electrostatic potential difference between the points. So I am writing the electrostatic potential difference between the points, and what this is the work done in displacing a unit positive test charged particle from one point to another point in an electric field against electrostatic force is called electrostatic potential difference between the points. Work done in displacing a unit positive test charge particle from one point to another point in an electric field against electrostatic force is called electrostatic potential difference between the points. Consider a point is displaced from A to B, then the work done on displacing the charge particle between A and B will be WAB upon a positive test charge particle is we have considered Q0. So it will be equal to the VB minus VA work done between the points. So this is the potential difference. And if we want to discuss about the SI unit, the SI unit will be the value of or unit of work done will be joule. So is joule upon coulomb. So joule per coulomb is the unit, and it is explained or it is termed as volt. About the dimensional equation, we know that the work done, dimensional equation of work done is m1 L2 t minus 2 upon the dimensional equation of charge is a1 t1. So it will be m1 L2 t minus 3 a minus 1, and work upon charge. Work is a scalar quantity, charge is also a scalar quantity. So it is a scalar quantity. So this is the scalar quantity. So electrostatic potential difference is the work done in displacing a unit positive test charge particle from one point to another point in an electric field against electrostatic force is called electrostatic potential difference between the points, and mathematically it can be expressed as VB minus VA is equal to WAB upon Q0, and SI unit is joule upon coulomb, and it is also named as volt, and it is a scalar quantity, and dimensional equation of electrostatic potential difference is m1 L2 t minus 3 a minus 1. So this is the potential difference or electrostatic potential difference, and if we consider the point outside the electric field means this is the beyond the limit of the electric field, and it is named as infinite. So if we consider a charge particle at infinite, means the charge particle is brought from infinite to certain point in an electric field, and that is the value of VA, means potential outside the point, outside the electric field, will be is equal to 0. And in this case, if we consider VA is equal to 0, then we can consider VB minus 0 is equal to WAB upon Q0, and it will be experiences, or it is named as electrostatic potential. Now the second point is electrostatic potential, and then we consider a point or condition in which the first point or charge particle is placed outside the electric field. Outside the electric field, again we consider VB minus VA is equal to WAB upon Q0, and here is VA is equal to 0 at A is at infinite. So in this case, VB is equal to WAB upon Q0, means if we consider a charge particle is brought from infinite to certain point in electrostatic field, then the work done is called the electrostatic potential at the given point in electric field. So the definition of electrostatic potential will be just as follows. Work done in displacing a unit positive test charged particle from infinite. Infinite means outside the electric field. From infinite to certain point in electrostatic infinite to certain point in electrostatic field called against electric field against electric force is called electrostatic potential. Electrostatic potential at that point. It is also a scalar quantity. It is has the SI unit is volt, and the formula is WAB upon Q0. This is the WAB upon Q0. So work done in displacing a unit positive test charge particle from infinite to certain point in electrostatic field against electric force is called electrostatic potential at that point, and the unit is, again, it is a volt, joule per coulomb, and it is a scalar quantity, joule per coulomb, and named volt, and it is also dimensional equation is same, m1 l2 t minus 3 a minus 1. So we have discussed about the two terms, that is electrostatic potential difference and electrostatic potential. In electrostatic potential, the both points which we have considered should be inside the electric field, and for the electrostatic potential, the one point must be outside the electric field. Now we shall define the 1 volt, dimensional equation is same, It is also a scalar quantity, just as electric field or electrostatic potential difference, scalar quantity. And SI unit is joule per coulomb or volt. Now we shall define about the 1 volt. 1 volt, there are two definitions. One is based on electrostatic potential difference and other one is electrostatic potential. So on the basis of electrostatic potential difference, if work done is 1 joule in displacing a unit positive test charge particle between 2 points in electrostatic potential is called the potential 1 volt potential difference between the points. And if a charge particle is brought from one infinite to certain point in electrostatic field and the work done is 1 joule, then the electrostatic potential at that point will be termed as 1 volt. So there are two definitions of 1 volt. The first one is one volt work done when 1 joule work is done in displacing a unit positive test charge particle between any 2 points in electrostatic potential between any 2 points in electrostatic field. Then potential difference between the points is called 1 volt. So this is the definition of 1 volt when 1 joule work is done in displacing a unit positive test charge particle between any 2 points in electrostatic field, then potential difference between the points is called 1 volt. This is the definition of 1 volt and the basis of potential difference. And now we shall define the value of 1 volt on the basis of electrostatic potential. And on the basis of electrostatic potential, we can define here when 1 joule work is done in displacing a unit positive test charged particle from infinite to certain point in electric field, then potential at the point is called 1 volt. So this is the value of definition of 1 volt And now this is all about the electrostatic potential and electrostatic potential difference.